This is mathheals.com, where you can find more links to math YouTube videos and computer science. Let's take a look at polar equations of conics. Now we got different forms. R is equal to EP over 1 minus E cosine theta. And if it's in that form, your directrix is perpendicular to the polar axis at a distance p units to the left of the pole. Now our next one is R is equal to EP over 1 plus E cosine theta, and directrix is perpendicular to the polar axis at a distance p units to the right of the pole. R is equal to EP over 1 plus E sine theta. Directrix is parallel to the polar axis at a distance p units above the pole. And R is equal to EP over 1 minus E sine theta. Directrix is parallel to the polar axis at a distance p units below the pole. Now, depending upon what your E is, determines which kind of conic it is, whether it's a parabola, ellipse, or hyperbola. If E is equal to 1, then it's a parabola, and the axis of symmetry is perpendicular to the directrix. If E is less than 1, then it's an ellipse, and the major axis is perpendicular to the directrix. And if it's greater than 1, then it's a hyperbola, and transverse axis is perpendicular to the directrix. That's why you're even concerned with the directrix on at least the ellipse and the hyperbola, because that tells you something about the major axis and the transverse axis. We'll come back to these forms, but let's go down here and take a look at our problems. Our first one here, we got R is equal to 5 over 1 minus sine theta. And it says identify the conic that each polar equation represents, also give the position of the directrix. And we'll come up here. Sine, so it's these bottom two. Specifically, it's a minus there, which is right here. Well, I need to identify what E is. Well, key to this form is we have to have a 1 here, which we do. And if I were to put a number before the sign, it would be a 1, like that. And I could rewrite the top part, because the top part should be E times something, and E is 1. And I could rewrite 5 as 1 times 5. So this would be E, and this would be P. Well, come over here. E is 1. That says it's a parabola. And that's the first thing it's asking. Then it says give the position of the directrix. Well, this says that the directrix is parallel to the polar axis at a distance p units below the pole. Polar axis. What in the world are we talking about there? Pole is right here. You can think of that as your origin. And this is your polar axis. Well, I've come up with this here. So if we look at our form, this is 1 minus E sine theta. Our very last one says the directrix is y is equal to negative p. So we got our parabola, and the directrix is y is equal to negative p. Well, p would be 5, so we got y is equal to negative 5. Now if I come up here, it's not so easy to see, but distance p units below the pole. Well, and it's parallel to the polar axis, so parallel will be this form, a horizontal line, so it'll be y equals. And it says p units below the pole. Well, if this is our pole, and p is 5, that means it's 5 units before, which is y is equal to negative 5. So those are answers. Okay, let's look at number 2. We've got R is equal to 3, 1 minus 2 cosine theta. Okay. Well, this needs to be a 1 here, so it is. So that part's okay. And if we have it in that form, this is our e. Whatever number's before the sine or cosine down here is your e. Now this top part we want to rewrite as e times p. So I wanted it as 2 times something. Well, I want it to equal 3, so this would be 3 halves. Because if I went backwards, the 2's would cancel and give us a 3. You can always, whatever this is here, you can put down your denominator. In this case, we had a 2, so I'll put 2 down there. And then whatever number's here can go on top. So this is e times p. So this is p. Okay, well, e is 2, and p is 3 halves. So let's see what in the world that tells us. E is 2. That's greater than 1, so it's a hyperbola. And it says, come over here. This is 1 minus cosine down here. So that's our first form. So it says Directrix is perpendicular to the polar axis at a distance p units to the left of the pole. So, and it's perpendicular to the polar axis. Well, if this is a polar axis, perpendicular is a line that's up and down, which is x equals something. And it says it's a distance p units to the left of the pole. Well, here's the pole. To the left of it would be a negative. So x is equal to negative 3 halves. Okay, let's look at our third one. R is equal to 5 over 1 minus 1/2 cosine theta. Okay, well, we got a 1 here, so that's good. We have had a 1 on all of these, actually, which means this is e, but top part I need to rewrite as e times p. So I want to rewrite it as e, which is 1/2, times something. This bottom part's okay. So e, and this will be p once we're done. So I'm trying to figure out, what do I multiply times 1/2? That'd give me 5. And I can do that over here on the side. What times 1/2, I'll say p, gives you 5. Well, if I multiply both sides by 2, we get p is equal to 10. And 1/2 times 10 does give us 5. So e is equal to 1/2, and p is equal to 10. Let's see what in the world that means. Well, e is less than 1, so that says it's an ellipse. Let's try that again. Ellipse. And if I come up here, it's 1 minus cosine, which is our first one again. 1 minus cosine. This is 1 plus cosine. This is 1 plus sine. This is 1 minus sine. So it says Directrix is perpendicular to the polar axis. So it's up and down. This polar axis, remember, is your x-axis. So it'll be up and down. So it'll be x equals something for our Directrix. And let's see what it says. P units to the left of the pole. Well, that'd be x equals negative 10. P units to the left of the pole. The pole is right here. So P units to the left would be over here and be negative 10. So x equals negative 10. Now, our next one is actually a graphing one. And I'm going to graph this by hand, and then I'll do it on the calculator. Calculator makes it very simple. I probably have room here, but let me start a new page just in case. And what is this called? Polar equations of conics. So, polar equations of Conics, page 01.pdf. And let's look at number 4. We've got r is equal to 4 over 1 minus sine theta. Well, we have a 1 here, which it has to be for our polar form of conic. That means that the number that's before my sine is 1. So E is equal to 1. Well, let's go see what in the world that means. E is equal to 1 means it's a parabola. So we're dealing with a parabola. Let's go down to our sheet for the parabola and see what we got. Looks like I need to figure out what P is. Well, E is 1. We got 1 minus 1 sine theta. And top part I want to rewrite as E times P. So we'll have 1 times 4. This is E, and this would be P. So we got 1 minus sine. 1 minus sine is our very last one. It says directrix is y is equal to negative P. So directrix is y is equal to negative P. So we've got y, and P is 4. Y is equal to negative 4. 1, 2, 3, 4. So that's our directrix. And it says focus is at the pole. So this is our focus. Now, if you remember from when we worked with parabolas before, your vertex is exactly in the center of those. So there's a distance of 4 here, so this would be our vertex. Now I'm going to plot some points. I'll come out here and look where my dot is. Eyeball the distance. This is the directrix here. So eyeball the distance from my point to the directrix and my distance from the point to the focus. Are they the same? They're not. So I'm going to keep moving this out until the distance is the same. And I am not very good at these. I just kind of wing it. Again, what I'm looking for is the distance from that point to the focus is the same as the distance from that point to the directrix, forming 90 degrees. I'll come over here now, and I'm looking at the distance from my point to the focus and distance to directrix. That maybe looks about the same. So that distance there should match this distance down to there. Now once you get a couple of them, you know what a parabola kind of looks like. You can go ahead and do that. And by symmetry, this side's going to look the same. And that would be our graph. So given the polar form, that's how you can come up with the graph. Now let's take a look at how to do it on our calculator. Now first thing, we got to put our calculator in proper mode, so press your mode. And I'm going to down arrow. And you see the line says function, PAR, POL. We're going to right arrow over and press enter on POL. Now I want to make sure I'm in radians, so I'll press mode. Again, oh well, I'm already in mode. Never mind. It's 11 o'clock at night. I'm brain dead. I'm going to go down and I'm going to choose radians. There we go. Now press Y equals. You see how these change now. We got R1, R2, R3. So we'll put in 4 divided by, and we have to put parentheses around the bottom. Anytime you have more than a single number or a single variable in top of your bottom of your fraction, you have to put parentheses around that part. So I have to put parentheses around the bottom part. And so then that gives us beginning parentheses 1 minus sine. Now press the X key and now puts theta on there. You can put a closing parentheses on the sign, closing parentheses on the denominator if you want. TI3, TI4 doesn't need them at the very end. And if I press zoom and choose Z trig, number 7, that's how we can get the graph on the calculator. It gives the same one that we got here. Okay, let's look at our next one. We've got R is equal to 2 over 1 minus 2 cosine theta. Well, we have a 1 here, so that's in good form. And this up here, this is e, of course, whatever number is before your cosine. And we want this as e times p. Well, this would be 2 times 1. So this is e and this is p. Although we won't, I don't think we use p on this particular one. 1 minus 2 cosine theta. Okay, so e is 2 and p is 1. Well, let's go see what e is equal to means. E is greater than 1 means it's a hyperbola. Okay, so let's go to our hyperbola formulas. And our bottom part has a 1 minus cosine. So we're looking for the formula with 1 minus cosine, which is our first one here. Okay, for vertices, it says plug in 0 and pi for theta. Okay, so let's find our vertices. And plug in 0, and we'll also plug in pi. We'll plug in that into our original. So we got r is equal to 2 over 1 minus 2 cosine 0. Cosine of 0 is 1. So that gives us 2 over 1 minus 2 times 1. 2 times 1 is 2. 1 minus 2 is negative 1, so that gives us negative 2. Let me double check that. Cosine of 0 is 1. 1 minus 2 is negative 1, negative 2. Okay, yeah. Now, theta. Theta equals pi, I mean. We'll plug pi in. So we got 2 over 1 minus 2 cosine pi. Okay, so we got 2 over 1 minus 2 cosine of pi is equal to negative 1. Well, negative 2 times negative 1 is a positive 2, plus 1 is 3, so we got 2/3. Okay, well, let's see what that gives us here. Now, theta is equal to 0. You can't think of these as plotting points. You have to think of more as in terms of polar form. So we're given an angle and given the r. Well, 0 degrees is right here. Negative 2 means I go in the opposite direction. So come over here, and that'd be a negative 2. That's one of my vertices. And then pi is over to here, and then we're going to go distance to 2/3. Well, since I'm over here, distance to 2/3 would be right here. And I made that too small, so let me try that again. Okay. There we go. So again, here's 0 degrees right here. And since r is negative 2, we go in the opposite direction. So that's why the point ends up here. Now, this one, pi, is over to right here. Remember, pi is this angle right here, and since it's positive 2/3, we'll go out in that direction, which would be about right here. That's our other vertex. Seems kind of weird, so if you're not comfortable with those, you probably need to refresh your memory on working with polar form. And let's see, 1 minus cosine, we're dealing with top formula. It says center is halfway in between the vertices. It says use midpoint formula. Well, you have to be careful with the signs on here. You don't want to use the signs directly off here. Let's look here. If I were to deal in, not even looking at the angles, this would be negative 2 and this would be negative 2/3. So negative 2 and negative 2/3, and I'll divide by 2. This is the midpoint formula, just dealing with two numbers. Multiply everything by 3. So this by 3 gives me negative 6 minus 2 over 6. That gives me negative 8/6, which gives me negative 4/3. Again, I multiplied everything by 3. the negative 2 by 3, the 2 by 3 here, and then this by 3. So negative 4/3. That's negative 1, and that'd be about right here, I guess. It's our center. Okay. Next thing it says is to find C. C is the distance between the center and the pole. Well, here's the center and the pole, and distance we want positive. Well, the center is at negative 4/3, so this will be 4/3. A is equal to C over E. So I got 4/3 divided by E, which was, what was E? E was 2. Which gives us, you can take this denominator, put it down here with a 2, so you got 2 times 3. That gives us 4/6 or 2/3. Okay. And then it says B is equal to the square root of C squared minus A squared. So that's 4/3 squared minus 2/3 squared, which is 16/9 minus 4/9, which is the square root of 12/9. And if I put that in my calculator, second mode, square root of 12/9, we get 1.15. Though really I can't do it to that precision. So B is 1.15. Well, how do we use that? Well, here's 1, so that's a distance of 1 there. This would be there. 1.15 would be a little bit past that. So let me put that in kind of bluish. 1.15 would maybe be right there. And negative 1.15 would be right there. Okay, now we go where our vertices are and we draw a line. Vertical line, that is, like that. Now where they intersect, that's where our asymptote's going to pass through. Now this is the box method for determining asymptotes, and I really don't show this when I'm covering the rectangular form, because it's just as easy to find it the other way, I think. When I say just as easy, having too many of these lines under here will just kind of confuse people. The green there is our asymptotes. Okay, now that we have those, these are our vertices, so we know our graph will go like that, and like this, and same here. Now how fast does it start skimming the asymptote? I have no clue. I'm just guessing there. But that would be our graph. Well, let's actually plug this in our calculator and see what we get. So I'm going to press my y equals, press clear, and I'll put in 2 divided by, and I had to put parentheses around the bottom because it's more in a single variable, single number. And I got 1 minus 2 cosine theta. Close parentheses on cosine, closing parentheses on denominator, even though you don't need those, and then graph. And you see we get the same graph. Now it puts the asymptotes on there pretty thick. I don't like how the calculator does that. I'm not quite sure how to shut that off. The asymptotes shouldn't actually be part of your graph. Just what you see here without the dotted lines is your graph. So let's save that. And then let's look at our next problem. I think it's number 6. Yeah, number 6. Okay, so we got R is equal to 2 over 2 minus cosine theta. Well, there's a problem with this one. If we look back at our forms, all of them have the number 1 as the first number down in the denominator. You got to have that, or it's not in polar form for a conic. So we can divide everything by 2. Well, 2 divided by 2 is 1. 2 divided by 2 is 1 there, minus. And there's an invisible 1 here, so I divide that by 2 and I get 1/2 cosine theta. Now, we're not going to actually use p on this. We only use that on the parabolas. But e would equal to 1/2. So if I come over here, e is less than 1, it's an ellipse. Okay, so let's go to our ellipse formulas that I came up with. And it looks like we have 1 minus cosine. I don't know why I chose so many 1 minus cosines for my examples, but it's the same idea on all the rest, so it's nothing exciting. So this says plug in 0 and pi for theta. Yeah, I wish I had done a different example, but oh well. So theta is equal to 0, and theta is equal to pi. And we'll plug those into the original. So we got r is equal to 2 over 2 minus cosine 0 degrees. Cosine of 0 is 1. So 2 minus 1 is 1, so we got r is equal to 2. And for this one, we got 2 over 2 minus cosine pi. Cosine pi is negative 1, so a negative negative gives us a positive 1. 2 plus 1 is 3, so we get r is equal to 2/3. Okay, here's my angle, 0. 0 degrees is right here. And it's a distance of 2, so we're going to go out to a distance of 2 in this direction. Pi, if I think where pi is, pi angle-wise is over to here. And distance 2/3, so we're going to go out a distance of 2/3 in this direction, which would be about right there. And those are our vertices, like that. I may make up a different problem for this so you can see a different type. But anyway, let's see what it says next. Center is halfway in between the vertices. Well, this one is, and again, I have to think of it not in terms of the angles, but where they really are positioned in terms of this being our center. So this would be negative 2/3. And this would actually be 2. Divide by 2. Multiply everything by 3. So that gives us negative 2 plus 2 times 3 is 6. And 2 times 3 is 6 there. So that gives us 4/6 or 2/3. Which should be about right there. And you'll know if you did it right, because does it look like it's center? Okay, so then what's the next thing it says? A is the distance between the center and a vertex. Doesn't matter which one. Well, that's 2/3. And this vertex over here is at 2. So let me go ahead and add 2 and divide by 2. This is the midpoint formula, find the halfway in between them. You could do that different ways. And I'll multiply everything by 3. So that gives me 2 plus 6 over 6. Gives me 12 over 6, or gives me 2. Obviously I can't add. I was going to say that didn't seem right. Let's try that again. 2 plus 6 is 8. I'll go back to second grade here. And that gives me 4/3. Okay, that seems more reasonable. 8/3, 8/6, 4/3. Okay. Then it says to find C. C is equal to E times A. Well, E, we said, what would say E was here? E is 1/2 times A, which we just said was 4/3. So that gives us 2/3. B is equal to square root of A squared minus C squared. So A squared minus C squared. So we got 4/3 thirds squared minus c squared, which is 2/3 squared. So that gives us 16/9 minus 4/9, which is 12/9. I think I've already did it in my calculator. That's 1.15. Okay. Well, what is b used for then? Well, we go from our center, and we're going to go 1.15. From our center, then, that's going to give us, these are along our major axis. These give us our minor axis. So 1.12, I go up, and that'd be there, and negative 1.12 would be somewhere around right there. And then we draw our ellipse. That's as good as I'm going to get by hand. And that's our answer. Okay, well, let's graph this on the calculator. So I'll press y equals clear, and I'll do 2 divided by, and put parentheses around the bottom, 2 minus cosine. And then graph. And that'll give us our same graph as we got there. Let me save that. And let me make up a problem. Let's see, that one looked like that. So I'll make up something similar to that. R is equal to let's say 4, 2, and let's go up to our ellipses here and see what's exciting. This is why I want to show one of these. So 2 plus sine theta. There we go. Well, I want to divide everything. I need a 1 here, so I divide everything by 2. So we got r is equal to 2 over 1 plus 1/2 sine theta. Well, e is equal to 1/2, which if I come up here, e is less than 1, it's an ellipse. So that's why we're down here using these formulas. This is an ellipse. Okay. And we got 1, what do we got? 1 plus sine. So it's the 1 plus sine, so it's top one. It says plug in pi over 2 and 3 pi over 2 for theta. So we've got pi over 2, and we got 3 pi over 2. Okay, we're plugging them into our original formula. So we've got r is equal to 4 over 2 plus sine pi over 2. Now sine pi over 2 is 1, so 2 plus 1 is 3, so we got r is equal to 4/3. By the way, if I had played with these numbers a little bit more, having 6, and so forth, I'd have a little bit more exciting problems. But these are all coming out a lot the same. Here we plug 3 pi over 2 in for theta. So we've got 4 over 2 plus sine 3 pi over 2. Now sine 3 pi over 2 is negative 1. If I look at my unit circles, 2 minus 1 is 1. 4 divided by 1 is 4. Okay, so let's see what that gives us. Now remember, pi over 2 is that angle right there. And since it's positive 4/3, that means we're going to go positive 4/3 in that direction, which would be right here. Now 3 pi over 2. 3 pi over 2 is down to here. So we're down to here, and it's a positive 4, so I'm going to go 4 out in this direction. Which would be that right there. Okay. Next thing, find the center. Halfway in between vertices. So let's find that. And again, you have to kind of imagine this instead of in this form. Think of it in terms of like a true x and y axis setup. So this up here would be a positive 4/3. This down here would be a negative 4. And divide by 2. So multiply everything by 3. So that gives me 4 minus 4 times 3 is 12, and 2 times 3 is 6. So that gives us negative 8/6 or negative 4/3. Negative 4/3 would be about right here, and that seems pretty reasonable considering it's halfway in between those. Then it says we find A, distance between the center and the vertex. Well, here's our center, negative 4/3, and we want to choose one of our vertices. I'll choose this one down here. Now think where this would be in terms of a real y-axis. That would be negative 4, wouldn't it? But what we're looking for is the distance. So we're not wanting negative here. We want positive. A is always positive. Okay, well, if I think of these as absolute values, this would be a positive 4/3, and this one would be a positive 4. I know that seems weird. Multiply everything by 3, so that gives me 4. 4 times 3 is 12. 2 times 3 is 6, so that gives us 16/6 or 8/3. Assuming I added correctly. Let's see, 12, 16/3, 16/6, 8/3. Okay, I think that's right. C. C is equal to E times A. I have no clue what E was. E was 1/2. So we've got 1/2 times 8/3, and that gives us 4/3. And B is equal to square root of A squared minus C squared. Well, A was 8/3, so we got 8/3 squared minus 4/3 squared. That gives us 64/9 minus 16/9, which is square root of 48/9. This is just a bunch of basic math. What's that give us? 2.3. When you plug it in your calculator, you can see it. That's a way to check your math. Okay, the reason why I wanted to show you one of this form is we came up with 2.3. Well, we already found our vertices here for our major axis, so this is our minor axis. So I'm going to go 2.3 out in both these directions. So from my center, I go 2.3 out, and that's about right there. And then by symmetry, this one will be about the same. So that'll give me my, if I could draw worth anything, that'd be our ellipse. Okay, plug this in your calculator. You press y equals, clear, 4 divided by, and put parentheses around the bottom. So beginning parentheses, 2 plus sine theta, a couple closing parentheses at the end, and then graph. And that give us our same graph. Okay. Now let me have you set your calculator back, because if you're going to use it for regular college algebra, like if you're sharing your calculator with somebody, you'll screw them up if you leave them in polar form. So we'll press mode. I'm going to go down to the line that says function, PAR, POL, SEQ, and we want to choose function. So I press enter on it. And then I'm going to press zoom, and I'm going to choose 6 for C standard. And now you're back to your standard viewing window. Okay, let me save that. And actually, I kind of like that problem. I may end up saving that. What was that problem? Okay. Duplicate that. That would have been problem 7. And we got 4 over 2 plus sine. There we go. So 4 over 2 plus sine. And that means this one will be 8. I hadn't realized I didn't have any examples of that other way. Not that it's real tricky or anything, but I want to show one. Okay, now let's just look at how to convert these to a rectangular equation. We got r is equal to 2 over 1 plus sine theta. Well, we'll multiply everything, get rid of the fractions. We'll multiply both sides by 1 plus sine theta. So multiply times r, and we'll multiply the right side by it. Do that. Those 1 plus sine thetas cancel there. R times 1 is r. R times sine theta is r sine theta. Equals 2. Now, to convert this to a rectangular equation, recall r is equal to the square root of x squared plus y squared. R squared is equal to x squared plus y squared. X is equal to r cosine theta, and y is equal to r sine theta. And then another one you may have to use, tangent theta is equal to y over x. So r here is square root of x squared plus y squared plus r sine theta is y equals 2. Now they're not very specific on what to do. It just says convert it to a rectangular equation. They don't say to write it in standard form. So technically this would be good enough. Now if I want to get rid of the square root, what I can do is take the y to the right side, becomes 2 minus y, and square both sides. Like that. And then this becomes 2 minus y squared. Over on the left side, the square root and the second power cancel, and we got x squared plus y squared equals 2 minus y times 2 minus y. So we got x squared plus y squared. 2 times 2 is 4. 2 times negative y is negative 2y. Negative y times 2 is negative 2y. Negative y times negative y is y squared. Now notice we have a y squared on both sides. Those can just cancel away when you have the same thing on both sides. So we got x squared is equal to 4 minus 4y. And this is a parabola. You know, I could go through and put it in the correct form and everything, but you know, really this is probably good enough. But let me take a little bit further. So I got negative 4y plus 4. Flip those around. Technically, the standard form, I want this as x plus or minus a number. I want a parentheses before the y, so I can always factor out the numbers before the y. Gives me that. And I want to rewrite the number out in front as 4 times something. Well, that'd be negative 1. And then from there, we could identify everything and work the problem down. Again, they don't give any kind of specific instructions. So this actually is good enough. Save that. It's like you always wonder when they're real vague with their instructions. Sometimes they do take it further and they just assume you're supposed to read their minds on what they're wanting. Let's take a look at this one. We've got r is equal to 6 over 2 plus 3 cosine theta. Again, we want to get rid of the fraction, so we're going to multiply both sides by 2 plus 3 cosine theta. So r times 2 plus 3 cosine theta is equal to 6. So that gives us 2r plus 3r cosine theta is equal to 6. Well, remember r is the square root of x squared plus y squared. R cosine theta is x equals 6. Well, I can do the same trick here. Though technically this is in the form they're saying. Take 3x over, so I get 6 minus 3x. Square both sides. When I do that, I got a number out in front. I have to square the number and square this. So this becomes 4 times x squared plus y squared equals 6 minus 3x squared, which gives us 4x squared plus 4y squared equals, when I multiply this all together, I get 36 minus 36x plus 9x squared. Maybe because it's 1130, but I'm having trouble thinking about that. Let me see. 36, 6 times 3 is negative 18. Yeah, it looks right. Okay, so guess I'll take these over to the right side. So I get 9x squared minus 4x squared minus 4y squared minus 36x plus 36. 9 minus 4 is 5x squared minus 36x minus 4y squared plus 36. Well, that's not come out nice at all, but then again, I made the problem up. I guess I'll stop there. But this would be a hyperbola if we were to go through and put in the standard form and so forth. If I were to factor out to 5, I'd have 36 over 5, and then completing the square on that would be just hideous. But anyway, that's our answer right there. Let's look at our last example. Six over 2 minus cosine theta. Okay, multiply both sides by 2 minus cosine theta. So we got r times 2 minus cosine theta is equal to 6. So we got 2r minus 2. Try it again. 2r minus r cosine theta. I think I'll go to bed after this one. Start making mistakes like that. So that gives us 2 square root of x squared plus y squared minus x equals 6. Let's see. Take negative x over. We got 6 plus x. Square both sides, and we get 4 times x squared plus y squared equals 6 plus x squared. So that gives us 4x squared plus 4y squared equals 36 plus 12x plus x squared. And take those over here. So we get 4x squared minus x squared plus 4y squared plus 12x. Actually, I'll leave 36 over there, which gives us 3x squared, and I could put the 12x. Now this would work out nice. Plus 4y squared equals 36. Assuming I didn't make a basic math error somewhere. And it's wrong to begin with. Okay. I don't see anywhere, but okay. So group the x's together, the y's together. Factor out the numbers in front of the squareds. So factor out of 3, and that gives us x squared plus 4x. Factor out to 4, so that gives us y squared equals 36. Complete the square for the x's. We don't have to do it for the y's because there's nothing there, but remember, completing the square for the x's. Take the number before your x, which is 4, times a half and squared. 4 times a half is 2, 2 squared is 4. So we got x squared plus 4x plus 4 minus 4, and plus 4, and then I'll rewrite this as y minus 0 squared equals 36. And I want to group these three together, group this one by itself. So I take 3 and multiply it times the first group and times the second group. So we've got 3 times x squared plus 4x plus 4 plus 3 times negative 4 plus 4 times y minus 0 squared equals 36. This one factors as x plus 2 squared. 3 times negative 4 is negative 12 plus 4y minus 0 squared equals 36. Take the negative 12 over, and it becomes a positive 12. Which gives us 48. Now we need a 1 on that side, so we'll divide everything by 48. It almost comes out really nice. Of course, it's obviously an ellipse, so we've got a plus there, but I didn't mention that. 3 and 48 both divisible by 3, so we got x plus 2 squared over 16 plus y minus 0 squared over 12 equals 1. And then to put it in the standard form, we take square root of the bottoms. But anyway, that's good enough. Again, they probably stop right here because they don't say put it in standard form. But I wanted to show that these right here, if you keep going, do give you our ellipse or hyperbola or parabola and so forth. So let's save that. And hopefully I haven't made any math errors for being late at night. Of course, I might have just made some piece of going senile, but 52 minutes. And let me save this. Oops.